Hi, my name is William Godel. I'm a politics PhD candidate at NYU, and I'm presenting work today done in conjunction with the Center for Social Media and Politics at NYU and the Stanford Cyber Policy Center. So the title of this paper is Weakness of the Crowd, Identifying Fake News with Crowdsourcing. So the motivation for this paper is misinformation, fake news, right? We know misinformation is a big issue. We know fake news is a big issue right now, especially during a global pandemic. And one of the biggest issues with misinformation is the volume and velocity of it, right? There's just too much fake news every day, and it enters circulation and sort of leaves the public sphere or any sort of attention within 48 hours. And there just aren't enough fact checkers in the United States to get to this and debunk it fast enough for it to make an impact. So one solution that we know social media companies are looking at, particularly both Twitter and Facebook, are looking at using some sort of non-expert or community-based solution. So asking their community, or maybe just hiring lay people to give them some information about this to help them identify fake or false news or misinformation. Another interesting part of this is that identifying fake news is an adversarial environment, right? Fake news is designed to be misleading. So it's an open question if crowdsourcing can work in this adversarial setting rather than a more classic crowdsource setting where, it's a bunch of people trying to guess the weight of a cow or something like that. In this setting, misinformation is trying to look like real information, and it's not clear that crowdsourcing can work in this kind of setting. So the research questions we're asking are exactly this. Can crowds of lay people identify fake news? The first way we're going to do this is with simple rules. So we'll get a crowd of lay people and we'll just use a simple rule like the majority of the crowd to see if these simple rules can give us, any purchase in trying to predict if something's fake news or not, or false news. Secondly, we'll use the information from the crowd and with machine learning to try to see if we can predict fake news. So take what the crowd says, take information from the crowd, and do a sort of classic supervised machine learning setting and see if that can help us identify fake news. But the main challenge for this project is not actually running, using these rules or running the machine learning algorithms, it's getting the data. So where does the data come from? So the data comes from a survey that we've been doing that's producing papers separate from this. But what we're doing in that survey is every day we send out a survey, and in that survey, we send out a bunch of news articles to people and ask them to tell us if those news articles are true, false, or misleading, or if they can't determine. That's generally what's going on. Specifically, what's going on is every day we'll source 5 articles. We'll send those articles out to people and we'll ask them to randomly evaluate 3 of them. And again, they'll tell us if that article's true, false / misleading, or could not determine. When we source those 5 articles on a daily basis, every one of those articles must have been published in the prior 24 hours. And respondents only have 24 hours to respond. So at most, every article that a respondent sees, they're seeing within 48 hours of its publication. So this is real-time evaluation of those articles. Additionally, when they get the articles, they're not getting a PDF. They're not getting an image. They're getting a link to that actual article. So they're going to see that article in the real world, in real time, exactly as they would if they were just going on the web themselves or clicking on their phone. Okay, and we're checking to see that they actually clicked that link. So every day, sending out a survey, and individuals are seeing news as if they really saw it. And when we send those articles out, we don't actually know the veracity of those articles. We just are sourcing articles from mainstream news sources and from some suspect news sources known to publish both true and fake news. We also wanted to make sure we had balanced sources of news. So we are sourcing from left-wing mainstream sources and right-wing mainstream sources, as well as suspect sources that are left, right, and then a bunch of sources that are actually neither. They're not easy to identify politically. So we call those neither. So we source 1 article from each of these 5 streams: 1 mainstream left, 1 mainstream right, 1 suspect left, 1 suspect right, and 1 suspect unclear. We do this every day. And when I say these streams, within a stream, we have many different media sources. So mainstream left might be CNBC and New York Times. Mainstream right might have Fox News, Wall Street Journal. I think each one of them had around 10. And then we had suspect sources as well. And we'd source randomly from one of those sources within the streams every day. When we sent these surveys out to lay people, respondents, we also sent them out to 6 professional fact checkers. These are people who work full-time at places like The Atlantic, and asked them to do a very similar survey to help us establish ground truth. So we would see what the 6 fact checkers said to actually figure out if an article was true or false or not. And here's a quick visual of what we're doing. On a given day, we'd source 5 articles. One of those articles might be from the New York Times. That would be our mainstream left. One would be from Fox News. That's our mainstream right. And then we have, again, our sort of neither nonpartisan suspect source, one left-leaning article from a suspect source, and one right-leaning article from a suspect source. That would go out to respondents, and that would go out to professional fact checkers. In the end, every article was evaluated by 90 lay people and our fact checkers. So the first takeaway from this is that people were pretty bad at this task. So if you look at the graph and you look at the bar on the left, when lay people looked at articles that were false or misleading, according to fact checkers, they labeled them as false or misleading only about a third of the time. So recall that people only have three choices. They can label an article false or misleading, true, or could not determine. When they looked at a false or misleading article, they only got it right a third of the time, meaning they were pretty much indistinguishable from random. When we look at true articles, we see the performance is better. On average, they're correctly labeling true articles as true 60% of the time. But recall that 40% of our articles are from mainstream sources, like the New York Times, Wall Street Journal, CNN, etc. So it's not particularly hard for individuals to say that an article from New York Times is true, or from CNN or Wall Street Journal is true. The big takeaways from this, and that we really explore in our other paper, are that individuals are pretty bad at this task. People, on average, they're very bad at identifying fake news or false news or misinformation. There is some differentiation, though, between true and false news, right? We can see that on average, they're labeling false news correctly a third of the time. They're labeling true news correctly around 60% of the time. So there does seem to be some signal in the noise in that respect. There is some differentiation between true and false news and how the crowd responds. Interestingly, there's significant variation in the difficulty of the articles. So for example, there was no false article that was correctly labeled by 50% of lay people. What that means is there was no of all the articles that were labeled false by the fact checkers, there was no false article where of the 90 people that saw it, more than 45 people correctly labeled it as false. We did have a bunch of false articles where maybe 40 people called that article false. But we also had some false articles where of the 90 people that saw it, only 9 people labeled it false. So there were some false articles where virtually no one correctly labeled it false. So the difficulty of the articles varied significantly. Okay, so what we can tell from our data that we're going to use is that individuals can't identify fake news particularly well, but can the crowd fact check fake news in real time? So in order to construct our data, the data that we're using from this survey, what we do is we divide every article into either a train or a test group, okay? And then we balance the train and test groups on the number of articles and the veracity of those articles. So in the end, we had about 38 articles of the 155 that the fact checker said were fake. We took 19 and put them in the test group and 19 and put them in the training group. And we also made sure to balance on difficulty. So at that point, all we had to do to create our data was sort of bootstrap crowds, right? So what we could do to, let's say, construct the training data is we choose an article from the training group, the articles that are assigning to the train group. We choose one of those randomly, and then we have 90 responses for that article. Well, what we could do to construct a crowd of 25 is we could randomly choose from those 90, randomly choose 25 with replacement, right? And that would be a crowd of 25 that evaluated that article. We could use information from that crowd to do this experiment. So that's what we did. We just bootstrapped crowds from the 90 responses that we had, and we did this for every article. And we did this for the training data and the test data. So we'd randomly choose an article in the training set or the test set, and then we'd randomly create a crowd based on the 90 responses we had for that article. We did this 20,000 times for the training data, and we did it 20,000 times for the test data. So in the end, we're in sort of a classic machine learning setting, right? We bootstrap 25 people. We have that crowd of 25. That's our features or our data for that observation. And then we have the label, which is what the fact checker said about that particular article. In the end, we realized that it was really easy to identify news from mainstream sources, and that really wasn't an interesting task, and it could sort of artificially boost performance. So what we did is we dropped every article that was from a mainstream source, and we only looked at articles that are from these suspect sources. So can individuals and crowds identify articles that are false that come from suspect sources versus articles that are either true or difficult to determine from suspect sources? And in the end, that left training and test sets with having about 11,000 observations each. Again, our labels were binary. They were from the fact checkers, and it was either this article is true, this article is false, or this article is not false. And in the end, for the test set, our baseline was that about 40% of articles were labeled fake by fact checkers. So if you just guessed that every single article was not false or not fake, you could get 60% accuracy on the test set. Okay. So the first thing we checked was the heuristic rules. Heuristic rules are transparent, they're easy to justify, they're very explainable, and they're also a great baseline for machine learning, right? We can say, okay, if the machine learning does well, how well could we do if we didn't even bother with machine learning? If we just did something really simple like majority voting, is the machine learning worth all the extra trouble? We also think that, in general, it's better if you have a system that's transparent and easy to explain, that's going to be much more normatively justifiable to your user group or your user base than something like a complex, maybe particularly opaque machine learning algorithm. In the end, we tried lots of heuristics, and I'm only talking about a small subset. But we tried, for example, just taking the mode of the crowd and using that as the prediction. We varied the size of the crowds. We used crowds balanced on partisanship, so a third liberal, a third conservative, a third moderate. We used unanimity rules, so maybe we sampled small crowds, and if they all agreed, then we used that as the signal. We sampled high political knowledge crowds, so individuals that have high political knowledge. We sampled high cognitive reflection crowds, so individuals that scored high on cognitive reflection. And then we also used Bayes' rule on the training data to create the probabilities, and then use that to make predictions for tests using Bayes' rule. So we tried a bunch. I'm going to only show you a very small subset of results. So here are just some results. On the left, you can see we have different types of crowds, totally random crowds, or partisan, or unanimity, crowd size. The column that really matters is accuracy. And you can see that accuracy is pretty low. Remember, our baseline is 60%. So, at best, we're getting around 64% accuracy here. And in none of our crowds do we find particularly good performance. So this is a small sample of what we've done, but it's reflective of the larger endeavor in that basically simple rules don't really seem to do much better than the baseline accuracy of saying that everything is just not fake. And precision and recall remain abysmal. So simple heuristic rules don't get you much in terms of predicting fake news. The crowd, at least as a first approximation, just using simple rules isn't very good, as I just said. One thing that we did notice was that larger crowds help, not too surprising. There is a little bit of signal there, so amplifying the amount of people participating definitely helps, but not by much. And high political knowledge and high cognitive reflection, which I didn't show, also helped, but again, by very little. And this is something we found in our individual determinants paper. People who have higher political knowledge and more are higher in terms of cognitive reflection do better at identifying fake news. But if you get a bunch of them in a room and do crowdsourcing, you still don't get much performance, at least based on simple rules. So now we'll turn our attention to machine learning. Now we'll be using the same crowds, but we'll be treating them more like information from the machine learning algorithm, just seeing what the crowd said, so taking the evaluations we're using before, but also creating a lot of features. So we'll create crowd level statistics, and we can use data from our crowd as well. So we can take, for example, the partisanship and tell the algorithms what's the partisanship of the people in the crowd, for example. We created a lot of features and experimented with different things. I'm not going to go into too much detail because of time, but basically we're taking what the crowd does and trying to create as much information from that crowd as possible for the algorithms. And then we're feeding it to some pretty standard off-the-shelf algorithms, with maybe the exception of the neural networks at the end. But pretty standard stuff, and doing all the trying to do it right in terms of cross-validation and regularization and all that kind of stuff. So here are results. Same as before. GBT stands for gradient boosted trees, and NN is neural networks. The main takeaway here, again, looking at the accuracy column, you'll see that neural networks with 25 people could only get up to 68% accuracy. So overall, this is just not amazing performance. We were kind of surprised at how limited the performance was. We expected things to be better. And if you actually, when we're doing this, you can easily get low 80s performance on the training set. But because we did a train test split at the article level, it means that that the variation in article difficulty is what's driving this low performance. Some articles are very deceptive, and some articles are not nearly as deceptive. And when you sample small, noisy crowds, so if we have we have total evaluations of 90, but if you're only sampling 10 or 25 people, you can get a lot of noise in terms of what those people say about that crowd. You can happen to get a lot of people that are very wrong, and that happens frequently. And when the variation of the articles differs a lot, it's very hard to do well on the test training set. On the test set. So what we're finding, at least, is that machine learning is very limited. The improvement in predictive power is really small. Factors that help with heuristics, like bigger, more informed crowds, they help, but they never make a huge difference. So everything we're seeing so far is that we're not looking at doing much more than 10 percentage points better than what the baseline is. And frankly, that just doesn't seem to bode particularly well for this task of predicting fake news. So those are our takeaways. We think that both individuals and crowds are not particularly good at identifying fake news. There doesn't appear to be a straightforward way to use simple heuristics or rules. So if you really wanted to have a simple way to use, let's say, a non-expert community to identify fake news, we couldn't find one. Crowds can be combined with machine learning to increase performance, but at least at this point, the overall performance is still pretty bad. This is not an algorithm you'd want to bet the farm on. So our main takeaway, at least, is that caution is very warranted with respect to using community. We know that social media companies announced over a year ago sometimes that in some examples that they're thinking about using communities or lay people or non-fact checkers, non-experts to identify fake news. We think caution is very warranted. We can't find evidence that that's going to work particularly well based on our survey data. And we have a very unique data set and the fact that we have these real-time evaluations of fake news and true news. So thank you very much for your time. I really appreciate you spending the time to attend the talk. Please, I welcome your questions and feedback. And if you don't have time to share questions or feedback today, please feel free to reach out to me at william.godel@gmail.com. Thank you.